Okay, so in this lesson we are discussing prime numbers, and before we discuss prime numbers we need to do some definitions real quick. The first definition we want to talk about is a divisor. And when you talk about a divisor is always a number that divides into another number. For instance, 3 is a divisor of 21 because 3 divides evenly into 21. So we call that a divisor. And maybe a better way to say it is a number that divides into another number evenly. So, and it might even be better of replacing a number in both of these with the word integer, which hopefully we're all familiar with. Okay, an integer that divides into another integer evenly. Okay, so that leads us to our definition for a prime number, and a prime number we use this word divisor to define a prime number, and that is a positive integer that has only one and itself as positive divisors. So the only divisors that are positive are 1 and itself. That is our definition of a prime number. So for instance, the most common examples would be a number like 7. Right? 7, the only things that divide into 7, the only divisors are 1, right? 1 goes into 7 7 times, and 7. Another interesting one is 2. 2 is considered a prime number because 1 and 2 go into 2. However, 1 we do not consider as a prime number. One is not a prime number. Okay, the other number that is often used in conjunction with prime numbers is a composite number. Which, when we talk about a composite number, we are discussing a number, or actually a better way to say it would be a positive integer that has a divisor that is not 1 in itself. So for instance, 12 is a prime number, or composite number. The reason 12 is a composite number is because 6 divides into 12 2 times, or 2 divides into 12 6 times, or 3 divides into 12, or 4 divides into 12. Okay, there are lots of factors for 12. Okay, so these are our 3 definitions that we're going to use. Okay, how we're going to use this, the first thing we're going to do is we're going to try to identify prime numbers. And so I've given you this chart of the first 100 numbers, and we want to go through and find out what are our prime numbers. So to do this, I'm going to go through and cross out easy ones. The first thing I'm going to cross out are the 5s, or the 10s, because we know that every number that ends in 0 has to be divisible by 5. So we know that none of these would be considered prime numbers, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 are all divisible by 10 or by 5, and so they're not prime numbers. Similarly, the ones that end in 5 are the same way. They're the same because when you divide 5 into them, you can divide into it. Now, however, 5 itself is a prime number, right? Only 1 and 5 go into 5. But 15, 25, 35, 45, 55, 65, 75, 85, and 95 are not prime numbers because 5 divides into all those. The other easy ones are the even numbers, right? When you go through the even numbers, 2, 12, 22, 32, 42, 52, 62, 72, 82, 92, right? Those are all divisible by 2. The same for the 4s, right? Each one of those are divisible by 2. Now, I did cross out 2 when I shouldn't have. 2 is a prime number. The 6s are all divisible by 2. The 8s are all divisible by 2. So in doing this, we can eliminate very, very quickly by taking all the even numbers out, all the numbers that end in 5, and all the numbers that end in 0, and we're already down to only about 40, I don't know, 43, 42 possibilities that could be prime numbers. Okay, those are the only ones that are left, so we know it has to be less than that. So now we can start thinking of what else can I do it? Well, why don't we look at multiples of 3? Right? If we look at multiples of 3, won't that cancel out prime numbers? So we start with 3. Well, 3 is a prime number, right? I know 3 is a prime number, and I know 2 is a prime number. 1 is not a prime number. So let's look at multiples of 3. So our multiples of 3 are 3, 6, 9. That goes away. 12, 15 is already gone. 18, 21 is now gone. 24, 27 is gone. 30, 33 is gone. 36, 39. All I'm doing is counting up by 3. 42, 45, 48, 51 is a multiple of 3, right? 3 times 17, so that gets crossed out. 54, 57 is a multiple of 3. 60, 63 is a multiple of 3. 66, 69, 72, 75, 78, 81 is a multiple of 3. 84, 87 is a multiple of 3. 90, 93, 96, and then finally 99. So now we've gone through and crossed out a bunch of other numbers by just looking at multiples of 3. So now actually what we've done is we've canceled out every multiple of 2, those are the even numbers, every multiple of 3, and every multiple of 5. Well, I don't need to worry about multiples of 4 because those are all taken care of by the multiple of 2. If a number is a multiple of 4, then it's a multiple of 2. Same thing about multiples of 6. If a number is a multiple of 6, then it's a multiple of 2 or 3, right? It's a multiple of 6 are all even, so they're all multiple of 2. But I do need to concern myself with multiples of 7. So we can just go through and count by 7. 7 plus 7 is 14, 21, 28, 35, 42, 49. There's our first one. 56, 63, 70, 77, 84, 91. That's kind of an obscure multiple of 3. That goes away, or multiple of 7. And then 98 is the last one. So now I've canceled out all the multiples of 7. I don't need to worry about multiples of 8. I don't need to worry about multiples of 9 because 8 is any multiple of 8 is an even number. Any multiple of 9 is divisible by 3, so I've already taken care of those. So I maybe need to look at multiples of 11, but it actually turns out that I don't need to worry about multiples of 11 because 11 times 11 itself equals 121. And so any other multiple of 11, right, we've done 11 times 9 is 99. So every multiple of 11 has to be multiplied by some that's between 1 and 100 is something 9 or less. And I've already canceled out all multiples of 11, or all multiples of things that are 9 and less. So that means I don't even have to worry about 11. Every number that I'm left over with here, 2, 3, 5, 7, 11, 13, I'm just going through my list here, 17, 19, 23, 29. These are all prime numbers, and I know they're all prime numbers because I canceled out all of the other multiples. And actually all I canceled out were the multiples of those single-digit primes. And that leads us to something we'll talk about here in our next video. So the primes are 47, and we can just list all these out. 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. those are all the prime numbers. You should start taking the time to know those. Those come up in a lot of interesting problems, and you should know all the prime numbers